A very good day and warm welcome to all those linking in to our Asia Pacific Malaria Elimination Network, the online course for vector surveillance and control. This particular module to be presented today will be on basic mathematical applications in vector-borne disease control programs. And the module will be presented by Dr. Pradeep Kumar Srivastava. Dr. Srivastava is a former joint director and head of vector control in the India National Vector-Borne Disease Control Program. And he has many decades of experience in integrated vector management, including for malaria, filariasis, leishmaniasis, and others. So he talks from experience. He has dealt with these issues hands-on for many years. He knows what he's talking about. So we thank Dr. Srivastava for his time spent on preparing and presenting this module. Thank you very much, Dr. Srivastava. I now hand over to you. Please proceed. Thank you.
Thank you, Dr. Leo and Dr. Tin, for inviting me and giving me this opportunity. And namaskar to all. Uh, we are basically dealing on mathematics under integrated vector management for vector control program. The basic need for understanding this mathematical application is why we require. So I have divided my presentation into where the mathematics is required, what kind of mathematics is required to understand the those applications, and ultimate objective to meet that this is basically how we are proceeding to get the desired doses of the insecticide wherever, whether in the form of larvicide or in the form of adulticide or in the form of we are doing for outbreak control the fogging operations. Presently, under vector control program, we have been using larvicide. Few are listed here. Basically, it is related to Indian context, but there may be many more in other countries, like mosquito larvicidal oil, temifos, biolarvicide groups, then pyriproxyfen and diflubenzuron. These last two, pyriproxyfen and diflubenzuron, they are the insect growth regulator category. Now, for indoor residual spray, which has been since 1950s onwards, it is being used especially on DDT, spray, malathion, and synthetic pyrethroid, the latest group of insecticide. Then we have been using long-lasting insecticidal nets also, and then for fogging also, there are two ways, thermal and cold fogging. So why we do require this? Now, if we discuss where do we require these kind of mathematics? We do require mathematical calculation because we want to know what quantity we are going to purchase. Then we want that how we will evaluate the product and how we should do the comparison for the going for the successful bidders. Then we need the assessment. What is the requirement if we go for daily use, or we calculate for monthly requirement, or we go for yearly requirement? So if we want to procure or obtain the insecticide with the conditions of the doses, with the condition of the formulation, with the condition of other logistics, what will be total required? So these are the issues why we require and where we do require these kind of mathematical calculation. So it is very clear that to estimate the requirement and actual consumption in the field, so that we can at the end we can assess that if the balance quantity is not as per the calculation, this is not going to lead us and the people are trying to manipulate the data. Then application dose monitoring. That is very, very important for the calculation purposes. I'm going to deal on that. Then based on that, whether the guidelines which has been issued by the national program people or the state program people or technically experts they have issued, then whether they are being followed in the field or not. And then if everything is clear in the mind for mathematical calculation, we can always start writing standard operating procedures for different level, because every stage there will be little confusion. So to avoid that confusion, what should be used by the spray persons, he should know little bit. Then above to him, the supervisor should know little more. Then above to that, so at different level, different kind of standard operating procedure can be done based on the mathematical calculation and what kind of mathematics is required. Now, basically, when we start off working on the mathematics, we should have little glimpse on that, that basically the insecticides, either they work by ingestion through mouth, or they are, I mean, they are taken inside the body, or they are taken inside the body through the inhalation, or they are taken by the contact. So most of these things, they are the entry points, and how they are working. So in fact, that will be a different chapter. But to understand this, once the insecticide gets into the insecticide will start working and the insect will be killed. So what kind of dose is required, basically optimum dose, and how to get that dose during our application. Now we'll start with the adulticide, indoor residual spray. Just for example, how to calculate the surface area. Say for example, if 3 meter and 3 meter room size is there, so it is an easiest calculation. 3 meter means 9 feet and 9 feet and 9 feet. So the four walls, if you look on here, one wall will have 3 into 3, length into width or length into height. So length into height, if you take 3 into 3, it becomes 9 square meter. So it is a square, so it has all four walls. So 9 into 4, it becomes 36 square meter. But the ceiling area also covered under spray. So another 3 into 3 is equal to 9. So total 5 surfaces will be equal to 45 square meter. Now, if we take on an average 4 rooms in a house, so if we multiply 45 square meter with 4, this becomes 180 square meter. Now, if take little bit buffer for kitchen and washroom, small rooms, 20 square meter, so it becomes 200 square meter. This 200 square meter, I have just kept red mark. Please remember this, because as per WHO, they have taken 200 square meter. How this 200 square meter has come, I am just giving an example. Now, next important issue for understanding the calculation is the exact area in the village, in the locality, and what will be the technical insecticide and its formulation and how to go about that. So, if we take a village which has got 5,000 houses, and the average sprayable surface area in previous slide I have mentioned about 200 square meter. Then the insecticide which we are supplied, say for example, we have taken lambda cyhalothrin, and the dose is 25 milligram per square meter. And the formulation which is available for water dispersible powder or wettable powder is 10% concentration. It means it is not the technical, it is the formulation with the 10% in active ingredient inside that. And then the duration of spraying means spraying for IRS is done basically to cover the epidemiological cycle. So usually we do 2 rounds, 2 months cover. So in 1 month, if we take 20 days working day, keeping Saturday, Sunday off, so 2 months means total 40 working days becomes. Now these are the facts. Based on that, the calculation will be made. Now come on the right side. Now treatment cycle is 2 times in a year, so that because about 8 to 10 weeks or 6 to 8 weeks for synthetic pyrethroid is the effective period, that is efficacy, residual efficacy of the insecticide. So to cover around 4 to 5 months epidemiological period in a calendar year, we require twice the spray. In case of special circumstances, yes, we have to go for another special round or additional round. But usually we go for 2 rounds of spray. spray to cover the 4 to 5 months. Now, it means the treatment cycle per year is 2 times, right? Now, what is the average output of a spray worker? One spray worker, he can usually cover 10 houses. It means 10 houses, and one house has got 200 square meter area, which I have shown in the last slide, and the left side, if you see my cursor, 200 square meter, one house. So one worker will be able to cover in 10 houses per day, that is 2000 square meter. This is very, very important point to remember, 2000 meter square area, which one person will be, one spray worker will be covering. Now, insecticide formulation, we have got 200 square meter, one house. We have got 25 milligram dose to be sprayed to get the dose 25 milligram. And we have got, so for one house having 200 square meter area, we do require 5000 milligram of active ingredient. Please mind it, this is active ingredient, that is 25 milligram at the rate of that for 200 square meter. Now, so for 5000 milligram insecticide, which has got formulation of 10% water dispersible powder or wettable powder, it means it is simple formula, since and therefore, if we require 10 milligram, we have got 10% of the powder, we have got 100% technical. So for 5000 milligram, how much we require? 5000 into 100 divided by 10. So we actually require 50,000 to get this 5000 milligram active ingredient. We require 50,000, 10 times more the formulation of 10%. Means if we mark it here, it becomes 50 gram. So it means a house having 200 square meter area, we do require 50 gram of the formulation available for us. Now, remembering those things, how do we work out the total requirement? Now, we have got 5000 houses in that village, which we have taken an example to sort it out. Now, one house will have 50 grams. So how much total for 5000 houses? Means for the village, it becomes 250,000 grams. Again, divide into, convert into, it becomes 250 kg. 250 kg of 250 kg of total insecticide required. And for 2 cycles, for 2 rounds of spray, we require, that is for 1 year, we require 2 rounds. So 250 into 2, we require actually 500 kg. Now 500 kg, and if we take 10% of the buffer for some kind of additional houses, or if we see some additional structures to be sprayed when we go to the village side, then we add another 50 kg. So it becomes total 550 kg for 1 year requirement for 5000 houses, or for the one village for 1 year. So it means the total area to be covered 5000 houses, we do require 550 kg of 10% of insecticide, which dose decided is 25 milligram per square meter. Now, if how much area will be covered with this, we just multiply 5000 houses into 200 meters square, it becomes 1000 meters square area. This is the calculation to calculate the requirement and the surface area conversion with that particular amount of insecticide. Now, another calculation is very important. How many spray workers would be required? Now, if total area to be covered, last sentence of the previous slide, that 5000 houses into 200 meters square per house, so 1000 meters square. Now, that area covered, if we divide by spray workers and the per cycle, it means one spray worker will be covering 2000 square meter area per day. That is 40 days he is working for 2 months. So he will be able to cover 80,000 square meter area. Now, total area you require 1000 meter square, and one worker will be able to cover 80,000. Just divide that 1,000 divided by 80,000, you require 12.5 or 13 workers. There is another method of calculation like that, that one worker will be able to cover 10 houses per day. So 40 days he is working in 2 months time, so 400 houses. And if total houses in the village is 5,000, so you divide by 400 by worker, again it is coming the same thing, 12.5 approximately. So we have to work it out for 13 spray worker for a area to be covered in 2 months time with 5,000 houses. I think I have made it very clear. And now come back. But in the field, so much calculation, as I have shown in the previous slide, the complicated calculation is to understand on paper and prepare ourselves before we go to the field. But for field, as I have insisted earlier, that for different level, different kind of SOP. So one example is set on the basis of all those calculations, and which is standardized, that for DDT, if we take the base, DDT 50% water dispersible powder. We have taken DDT base because DDT has been in use in the program. This was the first insecticide used for IRS. So for 1 million, that is 1 million population, we require 150 metric ton of insecticide if DDT is 50% and the dose is 1 gram per square meter for 2 rounds in a year. So if we take this calculation, standard calculation as a base, then if you want to calculate another insecticide, say for example malathion, the formulation available is 25% water dispersible powder. Malathion is required 3 rounds because it is 6 weeks only, the efficacy, and the dose is 2 gram, that is 2000 milligram. I have just converted into 2000 milligram because here also it is 1 gram, 1000 milligram per square meter. So if we work it out, high versus low. So the formula says 150 metric ton of DDT, and DDT available insecticide is 50% divided by the malathion dose lower 125% formulation. Then malathion required 3 rounds, whereas DDT requires 2 rounds, so high by low, so 3 by 2. And then malathion required 2000 milligram dose per square meter, whereas DDT required 1 gram, that is 1000 milligram. So you divide it 1000 into 2, 2 into 2, and then it becomes 900 metric ton. So for 3 rounds means for 1 year you require 900 metric ton for 1 million population to cover in a year. Take another example, say synthetic pyrethroid, delta methrin 2.5%. We do require 2 rounds of spray and the dose is 20 milligram per square meter. Now if we take DDT same 150 metric ton, then here the dose is 50% DDT, and the formulation of synthetic pyrethroid delta methrin is 2.5%, so high by low. Then both are 2 rounds, DDT also and the synthetic pyrethroid delta methrin also. Here 20 by 1000, here you require 20 milligram, here you require 1000 milligrams, so this becomes 60 metric ton. Now this is the one example. 2 example. If you take another example, this is simple calculation. Same formula you fit in 150, 50 by 10, 2 by 2, 25 milligram per square meter. So you require 18.75. Please mind it, because the formulation lambda cyhalothrin and which is 10%, but the dose is not same as in the case of this is 20 milligram. So the calculation is not simple. It should have been 4 times less. It should have been 50, but it is not coming 50. It is 18.75. That is how the ratio of 3.2 comes. And this is very, very important tool to work it out, that for a given population, your sprayable population to be covered under IRS, per year, what is your requirement? So when you start indenting the quantity of insecticide, or you want to float the tender, or you want to invite the quotations, you work it out that for a country like India, say for example, we have 60 million approximately, or 50 million sprayable population. So for 1 million population, we require 18.75 or 5% if you take 37.5 metric ton, or you take synthetic pyrethroid 2.5% 60 metric ton. So instead of doing that and giving the insecticide, if you know the mathematics, what we do usually, that we calculate in terms of 2.5% and we convert into, and then whosoever comes forward, he will be computed based on this, that in terms of 2.5%, what would have been the quantity required for 1 year to cover this many population with 2 rounds, and then what will the cost. So that is where the mathematics is very, very important. Now, the another important calculation is, we have so far known about the human resource calculation, we have known about the technical dose calculation, we have known now about the total sprayable surface area to be calculation, and we have come to know the about the total quantity of the insecticide and the cycles number required. Now, we require how to get the dose. So what we require for that, we require to understand about the little bit about the assembly and the pumps. Now, currently we are getting the spray pump is based basically on the discharge rate, because if exact amount of the insecticide is not coming out in the desired time, you are not going to get that particular dose. Now, to get that particular amount of insecticide with the flow rate, the most important point is pressure and the nozzle. Now, nowadays we are getting nozzle flat fan 8002E. Actually, E it is written for the EV spray. So 8002 is, you break it up, 80 and 02. 80 is the 80-degree angle spray swath, and then 02 is the zero point 0.2 ounce, so that is US gallon. And that is the discharge rate per minute. But that is taken at the different pressure, that is 3. Now, rate of discharge, usually we started with the spraying with the stirrup pump. Stirrup pump is like you stir simultaneously and go on pumping, that is manual pumping. And then there are another hand compression pump. So initially hand compression pump was not coming for even spray, means there was no control flow valve. This the new tool has come up last 2-3 years, this control flow valve that is fitted on the top of the nozzle, and that controls the as the name says, the flow through this valve is controlled for even spray. Now, usually the tank pressure is given at 40 psi, and swath which comes out of the nozzle is 75 centimeter, and overlap is 5 centimeter, which these are the important things, that so that because of the fringe area, the spray may not be even or diluted or coarse, so we overlap the spray when the next swath goes, so 5 centimeter is overlapping. And then, so that is why the 75 minus 5, the effective swath becomes only 70 centimeter. Now these 4-5 points will be very, very important for next slide calculations. Now, usually when we go to the village area for spraying, we get, I have taken one example, say for example 3-meter height and 6-meter, the total width area for spraying, if we take, so the wall height will be 3-meter and length will be 6-meter. Before that, if you take the area covered per minute, is basically, if you take 740, 700 is the 700 normally ml, and 40 ml per minute square per minute, the discharge rate usually when we go by that is ordinary hand compression pump or the stirrup pump. So 750 ml or 700 ml we have taken average, so that becomes 17.5. Just remember. Now, total area is 3 into 6, it becomes 18 square meter. Now, if we take the effective swath area, as I have told in the previous slide, is 0.7 meter, that is 70 centimeter. And if we take 3 meter, So one swath will cover, then another swath, then another swath, then another swath. So 0.7 into 3 meter, this becomes actually 2.1 square meter. On an average, if you take approximation, 2 square meter. Now, if this surface area 6 into 3 meter means 18 square meter you have to cover. So 2 square meter in one swath. So it means we have to go 9 times, 9 rounds we have to go for that. And that is how we demonstrate in the field. So you have to cover this whole 6 into 3 wall with the 9 rounds of swath. And then what is the time required? That if we want to take in 1 minute, that is 60 seconds. So one swath should have 6.6, 6 to 7, usually 5 seconds to 6 seconds we do. So that is what the SOP given to the workers, that one swath you should take 1, 2, 3, 4, 5. That's all. Now, this is another calculation. So like this we go. So 3 meter, this is the demonstration, and this is as per WHO practice also, and this is there in manual also, that 75 centimeter swath goes complete at the 80-degree angle with the 8002 nozzle. Now this 5 centimeter portion is overlapped. When the next swath comes, goes down again, and then again goes and again come down, again up and again down. So like this 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 9 rounds we do, and we cover into that many swaths. Now, if we have understood this, then now very important point we have to understand that one spray operator who will be spraying, he will cover a 2 meter height wall, that is 6 feet, 0.75 meter swath in 5 seconds, that is. And if he has to cover total area, so in 1 minute 60 seconds, how much he will be covering? So 2 into 0.75 means 1.5. Now 1.5, and then he has to cover in 5 seconds. So 1 minute means 12 times. So 12 into 2 roughly. So 24 meter he has to cover into 1 minute. This is very, very important point which we have, please remember. Now come to discharge rate and spray deposit rate. These two are another important things, because this is very important things. So if, there are two options. One is hand compression, the old hand compression, the new hand compression with control flow valve. This gives around 550 ml liquid per minute. I will show you how it comes. Then hand compression pump without CFV, without control flow valve, which we have been using earlier, that gives the output of 650 to 750 ml liquid per minute. Average we take 700 ml. Stirrup pump is always without CFE, so it is used 650 to 750 ml, because average is again coming the same with the old hand compression 700 ml. Now, how to calculate this spray deposit rate? How much in 1 minute, how much deposit will be there? So what is the total volume of the suspension which you have prepared is going in 1 minute? If you divide it by how much swath weight, that is 0.75, that is standard. And then what is the operator speed? That is how he is walking in 1 minute. Now, if you see this calculation, so if total volume coming out in 1 minute with hand compression pump fitted with control flow valve, that is 550 ml, and 0.75 meter is the width, and then 24 is the speed meter per meter per minute. So what happens? If you work it out, it becomes 30. Total spray deposit rate is 30 ml per meter square. This is why this calculation is important, because this is how we are saving the insecticide in shorter time. Now, if you calculate this versus the conventional pumps like stirrup pump or the hand compression pump without CFV, their average is 700 ml. Now 700 ml, if you fit it here, these things will remain same. So what will happen? This will come 40 ml per square meter. Actually it is 38.9, but we have taken average 40 ml. So what happens, in 1 meter square area you are putting 30 ml, whereas you are putting here 40 ml. It means the amount of insecticide we are depositing on the wall, here it is 30 ml and it is 40 ml, means the amount of insecticide is going more. It's not actually accurate. That is the one justification why we are now promoting the hand compression pump fitted with the control flow valve. So these are the different examples. If we take discharge rate 40 ml per square meter, that is the conventional pumps. Discharge rate average 700 ml. If you take 700 ml, it divide by 40, you are able to cover 17.5 square meter area. I mean, you have to then spend more time to cover the 2000 square meter area. If we take a different calculation rate, little less, 680 ml discharge rate per minute, divide by 40, it covers 17 square meter. If you take 750, it covers 18.7, you cover 780. So the range is 700 to 780 or 680 to 780. So different ranges, you are covering different area per minute, per square meter per minute, and that is how you have to cover the total, say for example 2000 square meter area. So you have to spend more time, more volume, more insecticide. Now conventionally, with these spray techniques, what we have been advocating in our guidelines, when we were using stirrup pump nozzle with steel nozzle with flat fan 60 degree, that we have given the guidelines that the spray swath should be 53 centimeter, not 75 centimeter, please mind it. So all guidelines, old guidelines were with the 53 centimeter. This overlap area was right, 75 centimeter and 7.5 centimeter and 38 centimeter. So 18 inches distance, that is also correct. But the number of rounds required for swath was more because the swath width was less with this flat fan nozzle. Whereas the current one, which is 8001 or 8002, the number of rounds with the same insecticide, because the swath is little wider, 75 centimeter, so you are covering in a shorter time with the same amount of insecticide. So that is how the latest technology is preferred. Now this I have already told, but this 19.5 square meter area is very important to remember, because 19.5 meter square area is covered in 1 minute, that is 750 ml discharge rate. It means in earlier, if you wanted our conventional method, one house will have 150 meter square. Now WHO says 200 meter square area. So conventionally we required 7.6 minutes. Now we require 6.2. So 1, 2, 3, 4, 5. Having understood all these spray complicated mathematics, which is very important and crucial to decide. So 18 inches, summary, 18 inches distance from the surface area, discharge rate between 740 to 850. This was the stirrup pump. And then you require 20 to 26 strokes. But anyway, internationally now, except India, I do not feel that any other places stirrup pump is being used. But we do say, I mean, this is very important because at different level you have to do different kind of SOP. So this was SOP for a stirrup pump operator, that 20 to 26 strokes per minute he has to do to get, so that with 4 to 6 inches plunger movement, and then that will create 10 psi at the nozzle tip. That is the standard. When you have 10 psi or 40 psi at the tank pressure, 10 psi at the nozzle, then only you will get proper swath for uniform spraying. Now what is happening when you are doing this? See, this spray, you are not visible any mark, but here you see down below the last slide, this is called as a bad quality of spray, and here only you require nozzle to be changed. So it takes a good understanding for all of you that if you do not use control flow valve, you are going to have old technology. But this is very difficult. It cannot be changed in overnight, but slowly you have to get it done. But just to give you an understanding that manual operation with the stirrup pump, how the variation will be there and different amount of insecticide will be used. Now, to sum up those, if you see the difference, these are the issues which I have discussed. Nozzle, if you take earlier stirrup pump 60-degree, whether a hand compression pump 80-degree, here also, but here it is zero point 0.2 ounces, here it is zero point 0.1. We are using now 8002 usually with the hand compression pump if it is fitted with control flow valve. Sorry. Then the pressure at nozzle is 10 psi. Here it is all regulated pressures. Tank pressure is 40 psi. Here it is basically when you are fitting to control flow valve and with the regulator it is 58 psi, that is 4 bar. And to get 58 psi, how much strokes you have to put? Here it is 24 to 26 for 10 psi getting at the nozzle. Here to create 40 psi you require around 40 strokes, but here the hand compression pump which is fitted with CFV you require 58 stroke because one stroke is around 1 psi it creates. Now discharge rate, which is another very important, usually 740 to 850 ml in 1 minute. Here also 750 to 1850 without control flow valve. But the moment control flow valve is fitted, if you are using 2 bar, it is 2 bar control flow valve, it is 650 ml. But in our vector-borne diseases control program, we are using 1.5 bar, which gives 550 ml. That is why in the slide calculation I have shown you, here I have shown you 550 ml. So that is how it 550 came into the picture, because 550 ml per minute with 1.5 bar. Then swatch size, here it was 53 centimeter, but now it is 75 centimeter the moment the nozzle TP changed. Average area of the house, here you are covering 150, here you are covering 150, but with the control flow valve we are covering 200 square meter, which is important to save the insecticide and the time. Application rate is, here there was no application rate, but usually it is 40 ml, but hand compression without CFV 40, whereas here it is 30 ml. All these calculations we have shown, and this is a ready reckoner chart I have made. Then area for swath for 3 meter height you require, here the effective is 1.44 square meter, whereas here it is around 2.1 and 2.1. Rounded figure we have taken 2. So you require more number of rounds and more human resource. Number of swath per meter, that is if 3 meter and 6 meter you are taking, here you require 12 to 13 persons. But in hand compression pump, where one person is doing, here because it was 2 persons were required, one for pumping and one for spraying. But here the same person, once you have created pressure, so you require only 9 persons. Sorry, number of swaths. 9 swaths only require, here you are requiring 12 to 13. And the area covered, here you were covering 30 square meter per minute, where here you are covering 20 square per meter. So everywhere you have got saving. So this is basically with the control flow valve, you have got a win-win situation. Just to show the back calculation, if you want to do the calculation in the field for checking up, if you have discharge rate of 750 ml per minute, you have got 10 liters of suspension to be consumed in 500 square meter, you require 10,000 ml for 500 square meter. Now, since this is the fact, since 750 ml discharge rate in 1 minute, so for 10,000 ml, you require 13.5 minutes. In 13.5 minutes, you will be covering around 500 square meter. It means in 1 minute, you will be covering 37 square meter. That's all. How many swaths? For 53 centimeter, effective that is 48 centimeter. You require one swath of 2 meter height is 2 into 0.48, that is meter I am covering because this is 2 meter. So it becomes 0.96 square meter. So to cover 37 square meter, you require 39 swaths. It means 39 swaths required for 1 minute. So 60 by 39, you require 1.6. Now this is very, very difficult, that whether in one go, can you cover in 1.5 seconds? Just say one or two, you cannot. That is why there is a big question mark. That is how we calculate and say that this is not correct technique. Now come back to again simplified formula. Our old ancestors they have given in the field. See, this is very simple formula. 234 they gave. What this 234 means? If you want, earlier DDT used to come in 75% WDP or wettable powder or water dispersible powder. Dose was 1 gram per meter square. In Indian context, we have decided 234. 234 means 2 pound 3 gallon 4 ounces. 2 pounds 3 gallon 4 ounces. Now, this was very easy to remember, and they used to give the earlier metric system, that two measuring system, that 2 pounds, one container they made which was containing 2 pounds, which can accommodate 2 pounds of the powder DDT powder, and 3 gallons bucket they gave. So you just fill up that, and then whatever suspension you prepare, you finish it into 4 ounces. 4 ounces, as per old technique, 150 square feet, that is 6,000. 1500 square 1500 square feet, so it becomes 6,000 square feet area. Convert into the new metric system, it's 2 pounds, roughly it comes around 660 grams. So we have taken 1 kg, 10 liters of water, and then 500 meter square. Now if you convert into 50% DDT, 334 means 3 pounds. 3 pounds is roughly around 1 kg. Just 1.1 something comes, so 1 kg. 3 gallons is same 10 liters, and 4 houses again we have just converted into roughly 500 square meter. So this is the standard formula for currently DDT 50%, 1 kg, 10 liters, and 500 square meter area. And this is also on a website of the Indian National Program. Malathion, same thing, 25%. I have just not put HCH or BHC, benzene hexachloride. So 6 pounds, 632 the formula. So 6 pounds, 3 gallon, 2 houses. Because you have to go 2 gram per meter square. It's not 1 gram. So the number of surface area will be half. So 2 kg, 10 liters, 250 square meter. Here it is 500 square meter. This is very, very important. So 2 kg in 10 liters become very, very thick for discharge from the nozzle. So you have to do 1 kg 10 liters and you have to spray 2 times. This is very ready reckoner formula. Now come back to larvicide. Little faster to understand that here we are using knapsack sprayer for larvicide, and larvicide knapsack sprayer, the flow rate is little higher. Instead of 740 to 750, it is 1000 ml, that is 1 liter per minute. This is very, very important for knapsack sprayer. Swath width is, it is 1 meter because it is little longer size, and walking speed, if you take 1 meter per second, so 50 it becomes 60 meters, but on an average, some hard, so we have taken an average 50 meter per minute. So if you want to calculate what is the rate of application, that is the amount of insecticide milliliter ml per meter square. So flow rate ml per minute, and then widths of swath, and then walking speed. So these three things you fit in. 1000 ml per minute is the flow rate, 1 meter swath width, and the 50 meter he will walk into per minute. So 20 ml per square meter if it is 1 meter wide area. How to calculate the concentration? What is the dose to be applied, that is gram per meter square, and the application rate, this which we have worked out here, 20 ml per meter square into 100. Now if you calculate the example, say for example that insecticide required to be sprayed, the dose 0.5 gram per meter square. Now 0.5 gram is the dose to be applied, 20 ml is the rate of application, so into 100, so it becomes the 2.5% formulation. So concentration will be 2.5% of the ready to use suspension. That is how we make 2.5% solution. Now, when you are doing the larvicidal application, if the breeding place may be small or narrow, so suppose it is 1 to 3 meter, it can be covered by one side only, and the lance will be 1 meter, and the gooseneck, that is little angled one, 120 degree, or cone or 8002 flat fan nozzle. So you can use any of this. Now, coverage speed should be 1 square meter per second. That's what I told you, 1 meter in 1 second if he's walking, and 1 meter width, the drain or the breeding side. So 1 into 1 it becomes 1 square meter. So 1 second he will be covering 1 square meter during spraying. But for wider area, he has to use lance without gooseneck, direct, no angle. So spray side to side and slightly above to the horizontal. So he will be covering little lesser, 6 to 10 square meter per second, because he will be using little longer lance and direct spraying little on the top. So it will come from the top. So it will be covering 6 to 10 square meter per second, because 1 meter will be speed. And if it is 3 meter or 4 meter or 6 meter, so 6 into 1 it will become six square meter. Only thing, you have to use little longer lines. And then with this calculation, he will be covering 10,000 square meter, or which is equivalent to 1 hectare. He will be able to cover 20 to 30. Actually, as per the calculation, it comes 17 to 28 per minute, but usually little somewhere some variation in the speed. So average we have taken 20 to 30 minutes. Right. This is the standard chart which we have displayed in the website of Indian National Program. The art. Different insecticides are given: MLO, Temifos, BTI, different strains. One is H14, one is indigenous strain, then one is 12S, and then the two insect growth regulator. I told you, diflubenzuran, 25%, that is water dispersible powder, and then pyriproxyfen, that is granule. So what is the class, what are the commercial formulation available, then what is the spray formulation. When we make it 2.5 cc in 10 liter, or 5 kg biolarvicide, or another one is 7.5 kg. So different formulation ready reckoner based on all those mathematics. So this kind of chart, if you want to prepare, you have to understand that kind of mathematics. And then for 1 square meter, what you have made ready to use solution, by say for example Temifast, you have to take 2.5 cc into 10 liters of potable. So you have got 10 liters ready to use solution. If you want to use 1 square meter, that is 20 cc. If you are to 50 linear meter, you have to use 1 liter. If you want to use for 1 hectare, you have to use 200 liters. So this is how the mathematics has resulted into preparation of such kind of tabular chart, and this is very user friendly for the people who are working in the field. Similarly, for the larvicide, if you see how this dose has come, I mean, if you are putting this ready to use solution in 200 liter or 1 liter or 20 cc, 2.5 cc or 50 cc into 10 liters of water, what the dose is coming. Now, see, 2.5 ml, you have taken actual gradient in 10 liters of the solvent. Active ingredient, basically here it becomes 1.25 gram, because if you are taking 2.5 ml, it is 50% EC. So I'm just giving one example. So it becomes 1.25 gram, half. Now 1.25 gram active ingredient is in 10 liters, means 0.125% concentration. It means the dose per square meter area will be 0.0025 gram. It means 2.5 milligram, and that is what is the dose what we get it. BTI 5% WP, 250 gram, 12.5 gram, 10 liters. So the dose becomes 25 milligram, 0.025. It means this indigenous strain, if you take, that is little higher, so you get 38 milligram. Similarly, for diflubenzuran, suppose you come, there are two places. One is for fresh water and one is for polluted water. So for fresh water, if you are taking 10 gram, then it becomes actually 25%, means active ingredient is 2.5 gram. Now, this you are put in 10 liters, you are using for this. So the concentration is 0.025%. And this you are using 2.5 gram into, say, for example, 10 liters you are using for 1 hectare area. So you are using 0.005 gram. It means 5 milligram dose is coming. Polluted waters, it comes double, 10 milligram, because you are using more amount. Similarly, for the pyriproxyfen also, pyriproxyfen 0.5% granular, this 2 gram, and 4 kg, 2 kg, 4 kg, that is for polluted, non-polluted, and polluted, fresh and polluted. So it comes zero point 0.1 gram and 0.2 gram. So this is the importance of the mathematical calculation to prepare such kind of ready reckoner chart which comes. Now based on that, the generalized formula in the Indian program, we have been using urban malaria towns, because in the urban area the larvicidal application was more. So we just gave the rough calculation that how you will work it out for 1 million population. 1 kiloliter 1000 liter for 1 million, and for MLO zero point 0.5 liter per capita, TEMI was 500 liter per million population. So to arrive this, that much calculation is required. For metropolitan there was no calculation, basically because they are self sufficient, so they can work it out. So but little support was given, and this red one is banned basically, so we are not going to discuss on that particular issue. Now come back to the last item, that is fogging. Fogging, you have to, sprayable area has to be converted into cubic meter, that is airspace. So the surface area into the total ceiling. So if you say surface area, if suppose the wall height is 4 into 2.5, so length is 4 and height is 2.5 meter, and 2 length and height is twice, one side wall and another side wall. So 4.5, 2.4 into 2.5 into 2. So the length of both the walls becomes 20 square meter. And suppose the width is little less, say it is 3, height will be the same. So 3 meter into 2.5, again 2 walls. So this becomes 15 square meter. So length and height, length and width, if you say 35 square meter, but then ceiling is also 4 into 3, because one is length and one is width. So 4 into 3, it becomes 12. So the total sprayable area for fogging to be covered is 47 square meter. Usually when you convert into the surface area into the volume area, it is of roughly two-third of that. So if 47 you convert into two-third of that, it becomes 31.3 square as cubic meter. But if you say length into height into width, that is the usual formula of the volume calculation. So length into height into width. So length into height into width is 4 into 2.5 into 3. So this becomes 30 cubic meter. So one word 30 cubic meter, and then if you work it out like this and take two-third, that is also coming 31.3. So roughly 30 cubic meter area comes for this particular sprayable surface. This is how the area is calculated. And then to cover that, there are one pyrethrum extract, which is plant extract 2%, and the preparation is made 1 is to 19 ratio, either with kerosene oil or with the diesel. Then cyphenolthrin, it is 5% EC, it comes, it is a synthetic pyrethroid. It is zero point 0.5 gram active ingredient per square meter. So 5 ml in 200 ml kerosene on 500 square meter. Flow rate you have to maintain 20 ml. But outdoor, cyphenolthrin is also recommended for outdoor. For outdoor, pyrethrum is not recommended. For outdoor, malathion technical, especially for the JE affected area, it was started. But if the amount is there and there is an outbreak, people they use for outdoor biting mosquitoes, even in malaria vectors also. So malathion is again 1 is to 19, one part malathion technical, and then 19 parts of the diesel, and then it is done with the fogging. Cyphenolthrin, when you are going for outdoor, the dose is little higher. It is 3.5 gram active ingredient per hectare. For that, you have to use 70 ml into 500 ml. Now, the issue is whether you are using 500 ml or you are using 1000 ml, you have to maintain the discharge rate so that you cover 1 hectare area with this. So that hardly matters depending on your, again, fogging nozzles and other things. Now, what we should do for space spraying? We must do the filling of the fuel tank, then petrol oil mixture must be very correct and mixed. Wear ear protectors if necessary, because sound will be more at the start point. Check for the leaks, otherwise there will be fire hazards. Check all gauzes and controls, and then do not touch the engine because it will be very hot. Now, at the time of closing, when you are using the fogging machines, drain the remaining insecticides. Very important. Put the nozzle hand in bucket with insecticide tank being on the little higher side. Open the insecticide flow valve so that insecticide will be dripping out. Unscrew the nozzle and insecticide will flow a little faster. Amount of insecticide in bucket should be measured to determine daily consumption so that you minus it and then see that with that particular nozzle discharge rate, how much insecticide you have used in one day. Then finally completely remove that nozzle, wash it in the kerosene and keep it overnight. Blow out orifice. Don't put anything inside the orifice. Then you put zero point 0.5 liter of kerosene into the insecticide tank because you have to run the machine for about 2 minutes so that it gets clean, remaining kerosene with the nozzle tip. Then rinse the insecticides and then spark plug should be cleaned. These are all at the closing time. People they forget all these things checklist, and this is very very important. Otherwise, your whole mathematics will be out of the question because then you require more insecticide, more defaulty nozzle rate, defaulty fogging. I think the last one will be for the aerial spray. We are not going to deal much in detail because it is not being practiced very often, but there are different kind of machines. Initially, C-847 aircraft or large helicopter, they can cover 6,000 because this is very very important. When sometimes some outbreaks and some aerial fogging is required, people they ask that how much area will be covered on daily basis because they have to arrange for the fuel for that. So 6,000 hectare per day with this C-47 or the large helicopters. Light helicopters, wing aircraft or small helicopter, they will be able to cover only 2,000 hectare area. Vehicle mounted, that is cold aerosol generator, LECO fogging machine, which was earlier coming. Now people are not using that because it's a big tank. 150 to 225, roughly around 200 hectare per day they were covering output. And then usual our vehicle mounted thermal fogger, that is TIFA, it is roughly 150 hectares per day. And then usual backpack ULB mist blower or fontan, that is 5 to 30, usually 7 to 8 hectares per day we are able to cover if everything goes well. So this is all about mathematical application which I wanted to tell you. Thank you very much and thanks for the opportunity.
Dr. Pradeep, very impressive. Clearly, you have a wealth of knowledge derived, accumulated over decades of hands-on experience in managing vector control programs, a depth of experience that you have been able to share the detail of with our aspiring vector control practitioners, learning from your experience in this session, for all that wealth of information and experience and the detail and the way you've explained it so clearly. We thank you sincerely. So sincere thank you from APMEN and all of us. We appreciate your time with us. So thank you, Dr. Pradeep.